9 cards are numbered 1, 2, 2, 3, 3, 4, 6, 6, 6. All 9 cards are placed in a line, making a 9-digit number. Find how many different 9-digit numbers can be made in this way if the even digits are all together. Okay, so we will need to group. Even digit would mean 2, 2, 4, 6, 6, and 6. These would be all together and their arrangement would be 6 factorial because these are 6 numbers and they have 6 available slots, so 6 factorial. Now, next we will consider this as a single number and then we're left with 1, 3, and 3. And altogether these would be 4 factorial because 4 numbers have 4 slots and this is 6 factorial. So final answer would be 6 factorial times 4 factorial. However, there are repetitions in this question, which is we have 2 and 2 twice, so we write a 2 factorial, times we have 3 and 3 twice, so another 2 factorial. Then we have 6, 6, and 6, so that's going to be a 3 factorial. So final answer would be 720. For part B, it says if the first and the last number are both odd. Okay, 1 and then we have 7 numbers here and another one here. So this is an odd number, this is an odd number. So there are 3 odd numbers. So this would be 3 P2, 3P2 would work. If you're considering both these, we have 3 numbers that have 2 available slots. So we'll use 3P2 for these. And then in between, we have 7 numbers left that have 7 slots, so 7 factorial, and then divided by repetitions, which is 2 factorial, 2 factorial, and 3 factorial as earlier. So 3P2 times 7 factorial divided by 2 factorial divided by 2 factorial divided by 6 factorial, which gives us 1260. Okay. Next, we have part 2. Three of the 9 cards are chosen and placed in a line, making a 3-digit number. Find how many different numbers can be made in this way if there are no repetitions. So if there are no repetitions, we could get a 1 or 2 or 3 or 4 or 6. And we could get 3 out of these 6. So the answer would just be, sorry, these are 5. So we could get 3 out of these 5 values. So the arrangements would be 5P3, which is 60. Okay. Next is if the number is between 200 and 300. Okay. That would mean the first number has to be 2. And after that, we have 2 more numbers. Okay. If the number is between 200 and 300. Okay, so if the first number is 2, then we may or may not have repetitions after that. So we're going to consider all the cases. So let's say there is a repetition here and we have another 2 in one of these spots. So we have 2 2s. Let's write 2 2s. So this is just 1P1 because its position is fixed. 1P1 is just 1. Then we have a 2 in one of these places. And then we have either 1 or 3 or 4 or 6 in one of these places. So one of the ways of doing this would be, let's say this is 2. So this would be 1P1 then, if this is 2. And this would be 1 out of the remaining 4. So I could do 4P1. And these 2 could swap their places as well. So we'll also have to times it with 2. So this gives us 4P1 into 2 is 8. Okay, next I'm going to consider 2 and another repetition, which could be 3, and we have 3 twice. So another 3. So this just has a single arrangement. It's just 2, 3, 3. There's no other way of arranging it because the first number has to be 2. And then 3 and 3 does not have any other arrangement. So this will be just 1p1 into 1p1 into 1p1. So that's just 1. Okay. Similarly, another repetition we could get could be 266. This also has just one arrangement, and there's no other way of arranging 266 if the first number is 2. Okay. Next, we can consider 2, and then there is no repetition after that. So that would be either we have 1 or 3 or 4 or 6. These are 4 numbers, and there are 2 available slots, so it will be 4p2. And like I said, this is just 1p1. 1p1 times 4p2. So 4p2 is 12. So now we add all of these together. Plus 10, we get 22.